Okay, this is a continuation of the previous lesson, lesson 24. This is part 2. We were working on greatest common factor or greatest common divisor, and now we're looking at it in the real world, like what would you use that skill for type of thing. Why would I need to know how to figure out GCF? So that's what we're going to be looking at today. Go ahead and get your notes ready and push play when you're ready to begin. Okay, so here's a story here. We have Layla and Angel. They're making centerpieces. Those are like the decorative things that you put in the middle of a table for the tables at the Halloween dance. They're making the centerpieces and they have 50 small pumpkins and 30 ears of corn. Okay, so they have 50 of these small little pumpkins and 30 ears of corn. And they want to know what the greatest number of matching centerpieces they can make using all the pumpkins and ears of corn, because they do not want to waste any of them. They've got 50 of those and they've got 30 of these. And they want to know how many centerpieces they can make that are exactly the same. They have exactly the same amount of pumpkin compared with ears of corns in each bundle, each centerpiece. So this is the type of question that if you're in this situation that you would use your knowledge of GCF. So if I have 50 pumpkins, I'll put pumpkin, P for pumpkin, and 30 ears of corn, I'm going to put C for corn. And I would go ahead and find the GCF because that will tell me how many centerpieces they would be able to make. So, so I just do the math like I did yesterday, or the day we did the first part of lesson 24, and I'm looking at these numbers to find out what number will divide evenly into both of them. Well, I notice they both end in a 0, so I'm going to go for the biggest number I can on that. A 10 will divide evenly into both of them. 10 goes into 50 5 times, and 10 goes into 30 3 times, because here 5 times 10 is 50, and here 3 times 10 is 30. Okay, I'm going to take a look at 5 and 3. Is there a number that divides evenly into both of those? No, there isn't. 1 times 5 is the only factors there, and 1 times 3. Nothing's going into both of them other than 1. It has to be other than 1, because 1 can go into everything. So what that tells me is that my GCF is 10. So if my GCF is 10, that means I can make 10 centerpieces, for 10 tables for the Halloween dance. And the next piece of information, this ladder is nice because not only does it tell me how many centerpieces I can make, it's also going to tell me how many pumpkins are going to be in each centerpiece and how many ears of corn. Because you look at this bottom number here. The centerpieces, all 10 centerpieces are going to have 5 pumpkins in them and 3 ears of corn in them. So what we'll see is we'll have 10 identical centerpieces that have 1, 2, 3, 4, 5 pumpkins and 1, 2, 3 ears of corn in them. So it's when you're trying to figure out things like that is when you use GCF. And if we do it this way, then we will have 10 exact centerpieces like that, and then we won't have any leftover small pumpkins that we have to throw away or any leftover ears of corn that we have to throw away. We've used them all. Okay, so let's do what we do, and I know this is going to take a little bit of time for you to copy this down, but go ahead and push pause and copy this word problem down. The Math Club members are preparing identical welcome kits for the 6th graders. They have 60 pencils and 48 memo pads. What is the greatest number of kits they can prepare using all of the pencils and memo pads? And they're going to want to be fair, make sure everybody gets the exact same kit. So go ahead and copy that down. Push play when you're ready to begin. So again, this is a type of question that we're going to look for the greatest common factor. That's the tool we would use to figure out how we can make sure that everybody gets the same amount of all of the items. So we have 60 pencils. Oops, 60 pencils. I'm going to put pencils. And we have 48 memo pads. I'll just put memo, like post-it notes. And I'm going to find the GCF of those numbers. Some of you might notice some numbers pop into your head. What I notice right away is that this ends in 0 and this ends in 8. So I know that 2 will fit evenly into both of those. How many times? Well, I can do the little shortcut real quick. 2 goes into 6 3 times. So that's 30. And 2 goes into 48. Well, 2 goes into 4 twice. And 2 goes into 8 4 times. And then I also notice again that ends in 0, that ends in 4. 2 will go in again. Some of you might have noticed that 6 goes in. It does. You can put 6 there. You would get the same. You would just cut out some steps. 2 goes into 30 15 times. The number 2 cuts things in half. And so I'm in small enough numbers where I know that half of 30 is 15. And half of 24 is 12. Okay. And I look at the numbers 15 and 12. A number that goes into both of these is 3. And remember a while back I was saying it's really important that you get those math facts memorized. Well, this is where it's coming into play big time. Know your math facts, know your multiplication facts, because when you look at this you can go, oh yeah, 3 goes into both of them because you know your math facts. 3 goes into 15 5 times, and 3 goes into 12 4 times. There is not a number that goes into both 5 and 4 evenly, so I'm stuck. And I take these numbers to the side, and I multiply them together, and that's going to give me my GCF. 2 times 2 is 4, and 4 times 3 is 12. So my GCF is 12. So the amount of kits they can prepare is 12 total kits. And because we use the ladder, we can even go more specific and say, in every one of these kits, in each one of those kits, how many pencils will it have? It's going to have 5 pencils in it. And how many memo pads is it going to have? It's going to have 4 memo pads in it. So because we use this tool, not only can we say how many kits there will be, but we can say how many of each item is in it. It's whatever we stuck on the bottom. So each kit will have 5 pencils and 4 memo pads. Now, I wanted to point out to you real quickly, you do not have to copy this part down. I'll do it in a different color so you know that you don't need to copy it down. I had mentioned to you that right in here, that some of you might have noticed that a 6 goes into it, so I'm going to show you what would happen if you did do that instead. So I'm going to just kind of do this over here. You do not need to copy this down. At the beginning, we noticed that a 2 went in, and then we got 30 and 24. And those of you who know your math facts might have seen 30 and 24 and said, hey, those are multiples of 6. 6 goes into 35 times, and 6 goes into 24 4 times. So, and then if you just multiply the sides, 6 times 2 is 12. You got the same answer, 12. You got the same amount of pencils and same amount of memo pads there. You just, what you did here, we just took 2 steps to do, because 2 times 3 is 6. So I just wanted to point that out, that you might notice different numbers dividing in equally, and that's fine. You'll get stuck in the same place, so it's okay. So I don't want you thinking, oh, I did that wrong if you did 2 2, if you had 2 and 6 and we had 2 2 3. You just noticed that 6 went in and we didn't notice it right away. Okay, so let's do a you do. Ferny is making identical gift baskets. Identical means exactly the same. So exactly the same gift baskets for the Wildcat celebration. She has 39 Wildcat stickers and 26 Wildcat bracelets. What is the greatest number of baskets that are going to be identical, remember, that she can make using all of the stickers and bracelets? So we didn't want to waste any. She doesn't want any left out. She wants to use them all. So go ahead and see if you can figure out how many total baskets, identical baskets she can make, and push play when you're ready to begin. Okay, so you have some sort of an answer, or you got to a point where you got stuck. So I'm going to go ahead and see what we get. So she's got 39 stickers and 26 bracelets. And so I'm going to use the GCF tool to figure out how many identical gift baskets she can make. So I'm looking at these numbers, and this doesn't end in a 0, 2, 4, 6, or 8. So 2 won't go into that. It'll go into that, but not that. It needs to go into both. It doesn't end in a 0 or a 5. It doesn't end in a 0. I'm going to try that super cool 3 rule. Hopefully you remember that. You should have it in the notes from the previous lesson. You can just flip your page back and look at it. 3 plus 9 is 12, and 3 does go into 12 evenly, so 3 will go into this number evenly. How about here? 2 plus 6 is 8, and 3 does not go into 8 evenly. So those are all my rules. There's got to be some sort of a number. 10, 11, no, 11 doubles things like 22, 33, 44. These aren't like doubled like that. 13 might work. 13 times, I'm looking at this, 13 times 3 should be 39. And 13 times 2 should be 26. Oh, that was a tough one. 13. Okay, 13 into 39 is 3, and 13 into 26 is 2. Okay, and then I am stuck at this point here because nothing goes into both of those. Those are both prime numbers, so when I get to that point, I know I'm stuck. So Ferny found out she can make 13 baskets. And then you guys, because you're using this ladder, you guys can go even further and say how much of each thing is going to be in everybody's basket. So everybody's going to have 3 stickers and 2 bracelets in their basket. So that was the answer. That was kind of a tough one to do as you do, but hopefully you did okay. If this makes sense to you and what we're doing, then go ahead and come see me about getting the closure questions. Oh, actually, wait, hold on a moment. There was one more thing I just briefly wanted to show you. Okay, I just wanted to show you that this can work with more than 2 numbers as well. And sometimes, you're putting a gift basket together and you're going to have more than 2 things in it. So you need to be able to do it with 3 or 4 or more numbers. So if I needed to find the GCF of 18, 45, and 63, I would look for what went into all of these. I recognize these right away as having 3 as a factor. 1 plus 8 is 9, 4 plus 5 is 9, 6 plus 3 is 9, 3 goes into 9 evenly. So I'm going to go with a 3. 3 goes into 18, 6 times 3 is 18. 3 goes into 45, I'm not sure, 15 times. And 3 goes into 63 to 21 times. I also noticed that 3 goes into each of these numbers as well. 3 goes into 6 twice, 3 goes into 15 5 times, and 3 goes into 21 7 times. And then there I'm stuck. These are all prime numbers, so I know I'm stuck. 3 times 3 is 9. That's my GCF. So if I was doing some sort of a gift basket with, and I had or flower arrangement, and I had roses, tulips, and carnations, I could make a total of, and I had 18 roses, 45 tulips, and 63 carnations. I can make a total of 9 identical bouquets. There's a word for you if you didn't know it already. That's an arrangement of flowers. It's kind of a French word that we use. Bouquet. I can make 9 bouquets of flowers that have exactly the same things in them, same amount and everything. And it would have 2 roses in it, 5 tulips, and 7 carnations in it. So I just wanted you to see that you can do that ladder with more than 2 numbers as well. All right, so if you understand the concept just fine, come see me about the closure. If you're still unclear on things, you can try rewinding and seeing if there's a piece of information that might fit into place that maybe you missed before. And if that doesn't work, then come see me in class and we'll see what we can help out with.